Today we're going to be going through the complete setup guide for getting Llama.c++ running inside an LXC on our Proxmox 9 host. This guide follows upon the prior guide that we put together just recently where we installed and set up the complete Proxmox 9 system. So this is kind of building upon that knowledge base. I'm not going to show you all the steps to install Proxmox 9, for instance, in this video. So building upon that, we're going to be installing Llama.c++, building it from source. I'm going to be showing you how to use Huggingface to access some models, and we're going to pull down a model, and I'm going to show you how to run that model. We're also going to wrap up by connecting it to OpenWebUI. So in the first guide, like I mentioned, we went through the steps of installing Proxmox, getting our drivers working, and also installing the OpenWebUI and Llama container. So the OpenWebUI component of it will be actually able to connect to multiple different backends, and one of the backends that we're going to connect to is going to be, of course, Llama.c++. We've got our VLLM guide on deck as well, and we've got some additional guides as well as some exciting extras that we will be getting to in the near term. But let's get started. I've already got this written up, so it should be actually quite easy for us to get this one rolling. Now, I'm going to assume that you followed through the prior guide here, so make sure you have gone back and installed, even if you just need to go back and copy some of the things to make sure the driver is installed and working. We had not installed CUDA Toolkit in the host. However, we do need to install CUDA Toolkit in the host, get that working. We're also going to need to install CUDA Toolkit inside the LXC container. That's a primary differentiator between what we saw with Llama and OpenWebUI and what we're seeing now for the demands of running something like VLLM, and also it will be needed for Llama.c++. So go ahead, start by typing in the first commands. You should have those already. Those are the basis of what you need for both. Now this next command that we're going to type here, you should actually not have that yet installed, so we should be able to see this install the Nvidia Toolkit. And at the end of it, it's going to pop us down to our bash RC, where we're going to make an addition to it. We're going to export the path, and then we're going to reboot. And at the end of that, we should be able to check a command called nvcc, and that means that we would have a full system that will function for us to be able to compile. So while this is downloading, let me just explain real quick. You want your CUDA Toolkit, which is a different set of software than the drivers that we installed last time, to be the same version numbers outside the LXC and inside the LXC. They both need to be on the same version. So if you're updating one thing, you need to update everything kind of. Also, this is another good reason for me to hit upon you don't need to be an update monkey and hunting down updates all the time. The further and further you chase this with the latest and greatest drivers, you're going to run into problems there. So we're going to be using CUDA 12.8 to avoid many of those issues. And it does take quite some time to install all the prerequisites. It's not going to be really fast, so you got to hang tight a little bit for this one. And in case it wasn't clear, I'm SSH'd into the host root of the Proxmox system here. Our bash rc export command here, just hit Control X and yes, and then we're going to type source.bash rc. And now we need to reboot, SSH back into that machine, and then type nvcc --version. And you should see something that looks very similar to this. Now it will vary just a little bit if this is something that you're watching later on based upon what the current release is. Again, don't chase the absolute bleeding edge. I think the bleeding edge is 13 or 12.9 right now. 12.8 is what the software vendors out there have been incorporating, so don't try to chase the leading edge of the Nvidia drivers. It will cause a ton of pain for you. I don't know why people don't say this more often. I definitely tried to do that, and it definitely caused a lot of pain for me, so be smarter than I am. Now let's go over here and create a container, and we're going to call this one Llama.cpp, and we're going to give it our password. Our template that we're going to use is the Debian 12 still. Pull this down. Now for the disk size for this, you do want to start at some point planning out your disk utilization. Now I'm going to go a little bit bigger so that I can demonstrate a very simplistic setup that we'll be able to run easily one of the probably better models, the Quinn models off of. And we're going to go up to about 40 gigabytes of size on this. However, Having a larger secondary storage that you can attach, or having remote Samba or CIFS if you have 10 gigabit or greater networking, is something you should definitely consider. We'll have a ton more on that here soon. As far as CPUs, I like to give it 16, move on to the memory and give it 512 gigabytes of main primary memory and 0 for swap. If it's going to crash, I want to know that it's going to crash and not see just massive performance degradation is kind of the reasoning behind that. For the static IP address that we're going to give our instance here, it's going to be 192.168.1.71 and then /24. So we gave Llama and OpenWebUI 70. We're giving this one 71. And the gateway IPv4 address is going to be 192.168.1.1. That's all you've got to do. And next, next, next. Okay, so as soon as it says task OK, you'll have your container over here. And the next thing we're going to do is add all of the device pass-throughs, just like we did in the prior video. So I'm not going to go crazy into it. You can, of course, follow along with that prior guide that showed you how to set up all of the pass-through devices very, very explicitly. Let me scroll down to it here so you can see that. If you need a refresher on how to do that, this is something you're going to do quite often. So kind of just, I guess, get used to doing this particular task is not a bad idea. So it starts right here, pass through GPUs to the LXC container, and it continues down. You can see all the things you're going to add in here as device pass-through, mount points, it shows you all of that, and then we test it out. So I'm just going to not go through 100% of that and recording all that. We're just going to jump to the end where it's all there, and then I'm going to test it out with you. Okay, so now we have the Nvidia device pass through. I'm going to go ahead and start the container up, and we'll come over to the console really quick. Looks like it's powered up there just fine. We're going to go root. Your user is root, so you're actually in the root directory here. We're going to come back to our proc0, do an ls, and you're going to see the driver that we had last time that we have, of course, installed. So the thing we're going to do is type pct push, and this is 101 for the container ID, the file that we are pushing into the container, and then space /root/ that. Now you could either pct enter 101 here, or you can come back over to your console over here. If you type ls, you'll see that we've got this now. So chmod +x, and type in the name of the file, /, and nv asterisk, and of course we're going to use no kernel modules. You're going to use that every time you use an LXC container. So no kernel modules. Use Nvidia Proprietary. Okay, okay. Gonna tell you some warnings about 32-bit software. Don't worry about any of that. You do not need to back up an X configuration. And so now this is installed. So I'm gonna pct enter 101, and that'll move me into the container. And I'll type reset really quick so we get a fresh view there. So the first thing that we're going to do inside our container is do a apt update. And there's quite a few things for it to update here. All right, next we're going to go ahead and copy all of our prerequisites for CUDA Toolkit 12.8 and install those. And this also will install the things that we needed to install for NVTop, BTOP, and HTOP, which are good things you can use to monitor, and also glances. Gives you really good kind of full system scope of visibility with glances. Pretty awesome if you haven't taken a chance to use it ever. Okay, so now we should be able to type NVTop and see our quad GPUs. Yep, there they are. So we'll do that. I'll also give you a real quick glances view. So in glances, you can see kind of some really good statistics about what's going on, and also a lot of disk activity stuff. So hit Control-C, reset that. Next, we're going to go ahead and install the CUDA Toolkit 12.8. All right, next we need to go ahead and export our path again inside the LXC just like we did outside the LXC. Control X, yes. And we're going to bounce it real quick. Just type reboot now. And you can up arrow and PCT enter 100 because it'll happen really quick. And then we're going to do NVCC hyphen version. And you can see we've got the parity between these two systems. At this point, we're going to do something that'll make our VLLM installation pretty easy backups. And we're going to take a backup of it. So Z standard is definitely what I think you should use for this. Now, local is going to get packed if you try doing a bunch of these on there, so don't try to do tons of them. You can also write base CUDA installed and confirmed LXC with Nvidia Toolkit and drivers. And this will be a really good way for us to restore from this backup for ID 102, which will be our VLLM. So we'll just click backup here real quick on it. Now, I wish that you got better information about LXC backup processes and LXC transfer processes. It's not quite as good as what you get for a VM. They really have first-class VM reporting tools. You can also keep an eye on this a little bit with, like I mentioned, glances, which will show some disk activity happening here on the NVMe drives. And great. And one of the cool things about this is that when you're using Proxmox, it's not going to eat up all of the space here for the way that we've got this set up. So it only took 5.56 gigabytes of space to back that up. So even though it was a 40 gigabyte container, it's only going to use what's actually parked on the disk. So that was not that bad. And we can use this now for our handy restoration for 102, which that'll save us a lot of steps and a lot of time and is a good practice. So we're also going to take a snapshot and we're going to say, about to install Llama.cpp. Just in case something happens during the installation. Oh yeah, that's right. Got to have hyphens, no spaces. So we're going to take a snapshot and call it about to install Llama.cpp. And the snapshot will happen actually much faster than the backup. So this will be done here in just a short period. Yep, and it's already done. So if there is a problem with the installation, you now have a safe way to revert for the Llama.cpp container and try the installation again. I'm just going to use the console. If you're in Proxmox, I'd recommend you do that also. So the first thing that we're going to do is git clone the repository for Llama.cpp here. This will pull everything down effectively. Next, we are going to run cmake on Llama.cpp folder. Get everything prepared, make sure that all the dependencies are there, all the compile flags are working, and you can actually read through this and it'll tell you what levels you're at and everything, which is very nice. As you can see, everything looks like it was good. So now we're ready to actually build. So we'll paste in this last one. Let me see if I can show that. That not showing is not what anybody's hoping for. There you go. So for some reason, the website strips out that extra hyphen. So just put the extra hyphens back in there for build, config. And this will take a while. It's going to build quite a bit of software. It is building for both GPU and CPU. This is like the big build. This is kind of everything under the sun. You can target things like Llama Bench or Llama CLI or Llama Server if you explicitly want to just have those built. Yeah, and I don't know if I'll be able to fix that on the website. I've tried to fix that a couple times and it just keeps stripping out the double hyphens. So I hope you're watching the video. All right, so for each one of these targets that got built, like Llama Server, the corresponding location is, so if you're interested in finding out more information about what the specifics of one of these can do, you can just type // paste that path in there, and then type -- help. And it'll basically give you quite a bit of information about what you can use for operators. And as you can see, there is a lot of information. Now, Llama Server, of course, has a ton of information. So we'll also check really quick the CLI. And you can see that there's different operators that you can use between these, so they're not just the same between all of them. And a lot of performance that you can get out of Llama C++ comes from optimizing for these. And the final one, which I think a lot of people will probably play with, is Llama Bench. And as you can see, this one's a little bit more simple. It's kind of got some pre-mades. They're all going to look for a model file, and currently we don't have any of the GUFs downloaded. Now for the next part, we're going to go ahead and download a model and run it. So there is a pretty cool thing that you can do here. So like Llama CLI, Llama Server, they can pull the model down also. So what we're going to do is append to Llama Server a command set that will download from Huggingface. So if you see here, we've got a Huggingface specified. We're going to download the Unsloth Quin 330B A3B Instruct 2507 checkpoint GUF, and that is going to be the Q4KM. We're going to host this server on port 9876. The host IP address is 192.168.1.71, and our API key that we're going to give it is nerdtastic. So I'm going to hit enter here, and you'll see that it's already running. If you haven't ran this yet, it will download the file the first time and then run it. So on subsequent runs, it won't do that because it's already got it downloaded like you're seeing here. I tried to capture that for you, but a guide can only get so complex before I just run out of energy. So next up, now that we've got this server up and running, which it's up and running over there, we're going to come to our OpenWebUI and Llama C++ connections. So this is actually really easy. So delete your OpenAPI connection under there is a decent idea, and then just start fresh. So we'll add a new one here, and you can see that I've already got in the URL, and you can get the URL from down here. And of course, our API key was nerdtastic. You click the little I to validate that is what you typed in. Yep. And /v1. Now it's going to look for models. It'll automatically at this point here. You can verify this is up and running by hitting the little check. It'll tell you it's server connection verified, or if it's red, then you've got something wrong somewhere and you need to mess around with it and find what you have wrong. Probably some launcher command. So the last part is don't forget to do this, click save. So once you've done that, go ahead, click save over here, and then come back to OpenWebUI. It'll look a little bit janky the way that it displays the name. You can change that by going to your admin panel, settings, models, and if you come here and edit this, make that big, you can come and, I think that's a decent representation name. Yeah, it looks like it. I'll put a hyphen there too. Okay, so come back over here and you can see that we're loaded up. So pretty cool. We've also got our Llama running, and now we've got our Llama C++. So we've got extra models available here. So I'm going to just toss it a howdy really quick, and it should fire up. Yep, there we go. And so you'll note that it's going really slow. That's because I don't have a number of GPU layers. So this is running just specifically on the CPU currently. So if you want to run this with GPUs, you need to use additional commands. So --ngl 99 should do. 99 will run all of them that are available. So we'll run this, and this should offload directly to the, maybe just one hyphen. Yeah, there you go. This will offload to the GPUs, and you can see that it builds up the buffer there, and when you see that, you know that it's actually running. And we'll hit regenerate. And you can see that is a massive speed difference. Massive speed difference. So you'll just ask it some additional things. So definitely make sure that you have your NGL set. You can do tons of really cool stuff, but this should allow you to run your Unsloth models from start to finish. I've taken you down that pathway in a manner that you don't get confused. So I hope you enjoy this, and I look forward to the follow-up here where we're going to do VLLM. There may be an extras, probably is an extras, where we're going to actually come back, revisit this, do a lot of tweaking and performance deep diving. And so there you have it. You can completely get up and running with Llama C++ locally and pull many of the latest and greatest models as soon as there's an Unsloth release for them, which I hope you appreciate that. That is going to speed things up for you quite a bit. If you haven't taken a chance, make sure to check out the channel history. A huge shout out to our channel members. Thank you very much for everything you do for the channel. You guys really do make this all possible. And I would urge you, go ahead, check out the rest of the Llama guide if you have not. The Proxmox 9 Llama guide, like I mentioned before, is the pathway to getting set up with this. We've also got our VLLM guide that you definitely want to tune into. I hope you guys have a really good understanding now of the reason why we're using Proxmox. Oh yeah, there's one thing that we forgot to do here that we're going to do right now, and that is we're going to take a second snapshot. So end to end basic setup complete. So we're going to take this snapshot, and now we're going to know we have a good end-to-end complete setup, which is really cool. So if we want to tinker, now's the time to start tinkering. If you want to go backwards to one of the checkpoints, very easy to do that. So this is why we're using the system the way that we're using it. There's a reason why I'm showing you everything in these steps that I'm showing you also. You now know how to run Unsloth models and download them in case you hadn't known how to do that before in Llama C++. And we've also got our Digital Spaceport article. Follow along with that on digitalspaceport.com. That'll be the most recent article. And this does follow up, like I mentioned, with the prior guide and video that we did, on setting up OpenWebUI in Proxmox 9, which in that video, of course, I took you through all the steps to get up and running. Of course, we've got our VLLM guide coming up, and then we'll have some deep dives as well as some sundry software that really does spice up having local AI and some of the good reasons to keep a local AI system running. If you're looking for build guides, check out the channel history. I've got tons of those, complete playlist with it, all of these things linked in the description below. Of course, we're working today on the Quad 3090 rig. Still to this day, one of the best around there for the bang for the buck, and does an amazing job at a wide variety of tasks. I hope you've enjoyed this. Let me know what you think in the comments below. And check out the videos here to get started if you are just starting on this journey. Of course, setting up the base of the system with Llama and our Proxmox 9 instance is covered in detail in that. Much of that knowledge feeds into this video guide, and from this guide you can go directly on to our VLLM guide.